Welcome to Unit 2, Lesson 11, Connecting Equations to Graphs, Part 2. This is a continuation of the previous lesson. Our learning goal for Lesson 11 is to analyze different forms of linear equations and how the forms relate to their graphs. We have 3 learning targets for Lesson 11. Learning target number 1, I can find the slope and vertical intercept of a line with equation ax plus by equals c. Learning target number 2, I can take an equation of the form ax plus by equals c and rearrange it into the equivalent form y equals mx plus b. And learning target number 3, I can use a variety of strategies to find the slope and vertical intercept of the graph of a linear equation given in different forms. We have one glossary term for Lesson 11, equivalent equations. Equations that have the exact same solutions are equivalent equations. Our first practice problem: what is the slope of the graph of 5x minus 2y equals 20? So what I want to do is show you how we can change this form of an equation into the slope-intercept form of the equation, and then look at how we can identify what the slope would be from this form. So, this is in standard form, which is ax plus by equals c. First thing I'm going to do is subtract ax from both sides. That gets rid of it on the left, and it leaves me with by equals c minus ax. Now I'm going to divide everything by b so that I can get rid of it on the left. Now I have y equals c over b minus a over b x. This is similar to the slope-intercept form. The slope-intercept form is y equals mx plus b. So when we're identifying this, slope is the number with x. So in this case, in standard form, that ends up being negative ab. And the y-intercept is the number without the x, so that ends up being c over b. So now what we can do is take the values from the one we're given and plug them in. So we're saying that a equals 5, b equals -2, and c equals 20. So if I want the slope, and the slope is negative a over b, then that is negative 5 over -2. The negative signs cancel each other out, and our slope ends up being 5 halves. So C is the correct answer. So you might want to make note that when it is in standard form, this is how you can identify the slope and the y-intercept from standard form. A is the number in front of x, b is the number in front of y, c is the number that it equals, slope is negative a over b, and y-intercept is c over b. If you have any questions about this practice problem, please use class time to ask for further clarification so that you are prepared as we move forward. Our next practice problem asks, what is the y-intercept of each equation? So for number 1, we have y equals 6x plus 2. Number 1 is in slope intercept form. The number by itself is the y-intercept. So on a slope intercept form, remember that is y equals mx plus b, and the y-intercept is b. So if we look at this, the 2 is the b. It's the number by itself. So the y-intercept equals 2. Number 2. This one is given to us in standard form, which is ax plus by equals c. And if you remember from the previous practice problem, we said that the y-intercept equals c over b. So we have 30 for the c, and we have 5 for the b. 30 divided by 5 is 6, so the y-intercept is at 6. And number 3, this one is not given to us in any form. So the first thing I'm going to do is I'm going to use the distributive property to multiply the 2 times the 3x and the 2 times the negative 4. 2 times 3x is 6x, and 2 times negative 4 is negative 8. Next, I'm going to add 6 to both sides. That gets rid of it on the left, and it leaves me y equals 6x, negative 8 plus 6 is negative 2. Now I have slope-intercept form. The y equals mx plus b. The y-intercept equals the b, and in this case, b is negative 2. So the y-intercept is negative 2. If you have any questions about how to solve this practice problem, please use class time to ask for further clarification so that you are prepared as we move forward. Our next practice problem says, Han wanted to find the intercepts of the graph of the equation 10x plus 4y equals 20. He decided to put the equation in slope-intercept form first. Here is his work. 10x plus 4y equals 20. 4y equals 20 minus 10x. Y equals 5 minus 10x. He concluded that the x-intercept is 1/2 0, and the y-intercept is 0, 5. What error did Han make? So let's look step by step. The first thing he did was subtract 10x from both sides. So he subtracted 10x from the left to get rid of it, and he subtracted 10x to get 20 minus 10x. So he's good up to that point. Next, to go from 4y to y, he divided by 4. That gets rid of it on the left. Then he also remembered to divide 20 by 4 to get 5, but then he forgot to divide the negative 10x by 4. Question number 2. What are the x and y intercepts of the line? Explain or show your reasoning. Han's first mistake is choosing to change the equation to slope-intercept form. The standard form it's in is the one that is useful for finding your x and y intercepts. So for number 2, to find the x-intercept, you're going to let y be 0. So you would have 10x plus 4 times 0 equals 20. Now 4 times 0 is 0. So you have 10x equals 20. You divide both sides by 10. This gets rid of it on the left. And you have x equals 2. So your x-intercept is 2, 0. To find the y-intercept, you're going to do the opposite. You're going to let x be 0. So 10 times 0 plus 4y equals 20. 10 times 0 is 0. So you have 4y equals 20. You divide the left by 4 and the right by 4. This gets rid of it on the left. And 20 divided by 4 is 5. So your y-intercept is 0, 5. If you have any questions about how to solve this practice problem, please use class time to ask for further clarification so that you are prepared as we move forward. Our last practice problem for lesson 11 asks, which graph represents the equation 12 equals 3x plus 4y? Explain how you know. This is a standard form equation, so it is good for finding the x and y intercepts. So the first thing I'm going to do is find the x-intercept. To do this, I'm going to let y equal 0. So we're going to have 12 equals 3x plus 4 times 0. 4 times 0 is 0. So y is gone. Now, to get x by itself, we're going to divide both sides by 3. This gets rid of it on the right. 12 divided by 3 is 4. So x equals 4, meaning the x-intercept is at 4, 0. So that would be a point right here. So we eliminate the middle graph as a possibility. So it's either the first graph or the third graph. Now we want to find the y-intercept. We're going to do this by making x 0. Three times 0 is 0, so that leaves us with 4y. Now we're going to divide both sides by 4 to get rid of it on the right. 12 divided by 4 is 3. Therefore, the y-intercept is 0, 3. And that point is up here. So the only graph that has the correct x-intercept and the correct y-intercept is the first graph. If you have any questions about anything we covered in these practice problems, please use class time to ask for further clarification so that you are set up for success as we move forward to the next lesson.